Okay, so we looked at vectors and how they can move figures, how they were moving them when you're just having it glide in a certain direction, up, down, right, or left. It's called a translation. So transformations is the chapter. It's over all the different types of movements. Translations with an L is this specific movement we're doing in 4.1. So a translation moves every point of a figure in the same distance in the same direction. So for the record, a translation is a rigid motion, meaning it preserves the shape so it's congruent to the original shape. So translations in the coordinate plane can be described by mapping notation. We started mapping notation when we were talking about vectors. So you do x comma y with an arrow, and then x plus some number, I'm going to call it a, and y plus some number b. It could also be minus if it's moving left or down. So each point shifts a units horizontally. A is the horizontal movement. And, sorry, not y, but b units, y plus b, so b units vertically. So the pre-image of the translation is the original figure, and then the image is the new figure. All right, let's look at this example. So it says, graph the image under the translation. So right here, it's giving us our transformation rule. So this is the rule. And the x plus 3 means it's going to go to the right 3. And the y minus 6 means it's going to go down 6. All right, so we take each point. So we start with A. It's negative 4, 1. So negative 4 plus 3, that's negative 1. And then 1 minus 6, that's negative 5. So let's go ahead and graph that. Negative 1, negative 5. All right, there's that point. Okay, B is negative 2, comma 4. So the x plus 3, negative 2 plus 3 is 1. And the y minus 6, 4 minus 6 is negative 2. So 1, negative 2. Put our point on there. All right, and then the point C, 1, 2, turns into C prime. Remember, C prime is just the image of the original C. So 1, 2, 1 plus 3 is 4, and 2 minus 6 is negative 4. All right, so 4, negative 4, I believe is right there. All right, and then D, negative 2, negative 3. We're going to do negative 2 plus 3. That's 1. And negative 3 minus 6, that's negative 9. All right, so 1, negative 9 is going to be all the way down here. And then we connect our sides. When I'm doing it on paper, I use a straight edge to make sure it looks the same. That way I can tell that the shapes are still congruent. All right, so my purple shape that I just drew is the image, and the black shape they had drawn is the pre-image. And if you look at it, let's see here. You can see that, like, take this point to this point. We moved to the right 3, that's the x plus 3. And then from there, we moved down 6, that's the y minus 6. And that was the translation of the image. Okay, let's look at this translations practice page. All right, so this I just think lays out really nicely with the mapping notation. So let's go ahead and write down what our points are. Okay, so this point right here, this is 0, 3. So if we use the rule listed above, x minus 1, y plus 3, then our new points are going to be negative 1, 6. Let's go ahead and graph that. Negative 1, 6. Okay, so now our next point, let's go ahead and do, how about this one right here? This is negative 4, 4. Okay, what would its new coordinates be? All right, its new coordinates would be negative 5, 7. So we're going to go ahead and put a point at negative 5, 7. Okay, and then let's go ahead and let's look at this point last. This is negative 1, negative 4. All right, what would its new coordinates be? It would be negative 2, negative 1, because remember, we went left 1 and up 3. Okay, so negative 2, negative 1 would be right there. And then we need to go ahead and connect our points to see our new shape. All right. And so this figure is the image of the pre-image. So the image was moved left 1 and up 3. Okay, so I'm going to go ahead and fill in these points right here for you. Okay, so go ahead and tell me, what would the list of the new coordinates be after you do the translation listed in the rule right here, the x comma y plus 3 rule? Okay, so the new points would be -4, 2, because the x doesn't change and the y adds 3, -1, 7, and 3, 0. All right, let's go ahead and pause the video and graph those points. Okay, so there's my new shape, and as you can see, the x didn't change and the y went +3, so it just simply moved up 3. It didn't have a left or right translation. Okay, so it says find the rule that describes the given translation. So you can always easily write a rule that describes a translation from one point to another point. So let's look here. We have z to y. So we're going from z to y. All right, so if you look, we're going left 2, all right, and down 4. So to write that rule, it'd be x comma y arrow. You have to have that beginning. You can't just put the end part. It's all together. It's indicating that the original point changes by doing left 2 is x minus 2, down 4 is y minus 4. Okay, let's try another one. All right, so let's look at, it says y to w. Okay, y to w is right here. So let's look at the change. So it goes, we're doing horizontal change first. So it goes to the right 4 and then down 2. So right 4, down 2. Okay, so how that changes, the right 4, that's the horizontal change, so that's x plus 4. And the down 2 is y minus 2 because that's a vertical change. All right, let's go ahead and try another one together. So w to v. All right, that's right here. Okay, so what is its horizontal change and what is its vertical change? All right, so it goes to the right 2 and up 2. So it's going to be x comma y, and then it's going to be x plus 2, there's right 2, and y plus 2, there's up 2. Okay, I'm going to go ahead and have you try from z to u. Write the mapping rule from z to u. All right, so the mapping rule from z to u, it goes, let's see, right 5 and down 1, so that's going to be x plus 5, y minus 1. All right, I'm going to go ahead and have you try the mapping rule from u to y. All right, the mapping rule would be x comma y arrow, and it goes left 7, so it's x minus 7, and it goes down 3, so it's y minus 3. Okay, and last but not least, what is an isometry? An isometry is a rigid transformation. And it maps every figure onto a congruent figure. So that the pre-image, the original, and the image, the new one, are congruent figures. So if it's a rigid transformation, it's an isometry. They go hand in hand. So an isometry or a rigid transformation means that the pre-image and the image are going to be congruent figures every time.